Okay, so did everybody put that down? Solving trig equations, 19.7? Check. Okay, so here's the first example that I'm going to do. I'm just going to show this to you by through examples. Okay, so we have 4 cosine squareds of x minus 3 equals to 0. So when you are solving trig equations, your goal here is basically to isolate the trig piece. So in this case, we're working with cosine. So how would you isolate the cosine? Almost. There's one thing I would do first. Add 3 first. Okay, so we basically are just trying to get cosine by itself. So we'd have 4 cosine squared is equal to 3. Then I would divide by 4. Good. So now I have the cosine squared is equal to 3/4. What would you do from there? Square root it. Good. Okay, so if I square root a fraction, I just square root the top and I square the bottom. So what's the square root of 3?
Square root of 3 over 2.
Okay, good. And since I'm solving an equation, what else do I need to have? Plus or minus. Good. Okay, so at this point, I now grab my unit circle. Okay, and since my x is after the cosine, what am I looking for? What is the x going to be? What's that? So what is my answer going to be like? Okay, yeah. So it's going to be the angle. I'm looking for an angle. So I'm trying to figure out where the angle fits this criteria. Okay. So on this particular example, do you see how it says between 0 and 2 pi? Are we working with radians or are we working with degrees?
Radians.
We're working in radians. Okay, so we're looking for a radian measure where the cosine, which is which variable, by the way? The x. So I'm looking for where the x value of the unit or of the ordered pairs is either a positive square root of 3 over 2 or a negative square root of 3 over 2. You should see 4 different places. What are they? So give me a radian measure instead of a degree. Wait. The x. The x value is square root of 3 over 2. There you go. 5 pi over 6. 7 pi over 6. And 11 pi over 6. Everybody okay with that? X, Y. X goes first, Y goes second. In your ordered pairs. It's been a while, since we worked with ordered pairs. Alright, let's try another one. Ready? Number 2. So we have the square root of 2 times the sine of 2x is equal to 1. Okay, so I'm going to isolate the sine. What would you do first? What? Yeah, I would divide by the square root of 2 first. Okay, so what I have here is the sine of my stiff. And it's going to equal 1 over the square root of 2. And before I write this, I'm going to simplify 1 over the square root of 2 because we don't want to have a square root in the bottom. If you multiply by the square root of 2, you get the square root of 2 over 2, right? Okay, so now I grab my unit circle, and the sine is which one?
Y.
The y. So I'm looking for where the y on my unit circle is a positive square root of 2 over 2. So at pi over 4 and 3 pi over 4. Now did you notice what I did when we solved this? There's a 2. Okay, so I don't touch the 2 that is of the sign until after I've gotten rid of the sign piece. Okay, so now if I have 2 times x, how would you get rid of that 2? Divide by 2. So what I'm going to do is divide each of these 2 answers by 2, and that will be the value of my x. Okay, so what is pi over 4 divided by 2? Pi over 8. And then what is 3 pi over 4 divided by 2? 3 pi over 8, good. Does that one make sense? How to work with, yeah? Ooh, okay, so do you remember that the cosine is always the x value, and the sine is the y, and tangent's y over the x? Okay, if you can't remember that, write it down on your unit circle right now. Okay, so write down sine is equal to y, cosine is equal to x, tangent to y over x. When we are working with a tangent. Right now. Exactly, on question number 3. Alright, so number 3, let's try this one. Everybody ready? No? So 3 times the cotangent squared minus 1. So what is your first step? Add 1. It's like,
So I'm sending hand signals over here.
okay, then what would you do? Divide by 3. So cotangent squared is equal to 1/3. What would you do from here? Square root, good. Okay, so if I square root the top and square root the bottom, what is the square root of 1?
1.
What's the square root of 1?
1.
For some reason, a lot of people forget that. What's the square root of 3? The square root of 3. Oops, I shouldn't have wrote that squared, my bad. Excuse me. All right, now, do you notice that we're working with a reciprocal trig function? Because cotangent is the reciprocal of tangent. Okay, so I'm going to show you a little trick that you can use on other pieces. So when you're working with cosecant or secant. Okay, so all you're going to do is you're just going to flip it. So the reciprocal of cotangent is, okay, tangent, yeah, so tangent is equal to, and now we're going to flip it and call that equal to the square root of 3 over 1. Which is, yeah. And I'm going to leave it like this and I'll show you why. Okay, by definition, tangent is what over what? Y over x. So that's basically telling me that y over x is going to equal the square root of 3 over 1. Okay, so if you look at your unit circle, do you see a y value of a square root of 3 anywhere? What do you see? So every place that you see a square root of 3, it's a square root of 3 over 2, and what's the other coordinate? 1/2. Okay, so check this out. If I go like this, if I have 1/2 and I have a square root of 3 over 2, and I do y over x, so my y would be a square root of 3 over 2, and if I divide by 1/2, what's that the same as? Multiplying by the reciprocal, right? So if I flip 1/2, that's the same as 2 over 1, and what happens? The 2's cancel. So do you see what has happened? They're giving me the reduced form of this. The 2's have already canceled. Okay, so the ordered pair that I'm looking for here is going to be where the x is the 1/2 and the y is the square root of 3 over 2.
Math is doing work already for me.
Okay, did anybody notice what we should have added on here way back in solving the equation? Yeah, we forgot our plus or minus. Sorry, you guys should have yelled at me. Go ahead, Zach. Where did I get what? The 2?
Yeah.
I got it from the unit circle. So if you look at your unit circle, every time you see a place where there's a square root of 3, it's a square root of 3 that's over 2, and the other piece is a 1/2.
That's got lots of percent.
Okay, so I'm looking for this kind of scenario where we have an x of 1/2, the y is the square root of 3 over 2. We can have plus or minus versions of that. So I need 4 places where we have a x of 1/2 and a y of the square root of 3 over 2. Where do you see those? Pi over 3. 2 pi over 3, so that's the negative version. 4 pi over 3 would give us a positive version. And 5 pi over 3, good. Is everybody okay with that one? Okay, so that was kind of a good example to show you how to work with reciprocals as well. All right, let me do one more. I'm going to do this question number 5. Okay, so number 5 gives us a sine, and within the same equation there's also a cosine. Okay, so sometimes it would require the use of your trig identities in order to solve equations, or if you have multiple trig pieces, you're going to want to try to factor. Okay, so before we do this one, what are my methods of factoring? How can you factor anything?
Complete the square. 1.
Ooh, you can complete the square. That's an option. I don't know if we're going to go there today. That sounds scary.
Common factor.
Okay, yeah, greatest common factor. I like that one. Okay, we could use potentially an easy method or potentially a hard method.
Oh, right.
Those ones. Okay, so let's try greatest common factor. Can I pull a greatest common factor out of those two terms?
Sine of x.
A sine of x, good. So if I pull a sine out of both pieces, what would be left out of the sine?
1 minus sine.
1 minus. Now if I pull the sine out of 2 sine cosine, what's left? 2 cosine, right? Because I'm pulling the sine out, right?
Right. I was thinking the square.
Okay. So now, anytime I've factored, what do I do next if I'm solving an equation? What do you do with the two quantities? Set them equal to 0. Okay, so all I'm going to do is I'm going to set both of my two quantities equal to 0. So I'm going to have a sine of x equal to 0. And I'm going to have 1 minus 2 cosines of x equal to 0. Okay, so if I solve my sine of x, grab your unit circle, because it's already solved for the sine. And since sine is which variable? The y. Where do you see a y value on the unit circle of 0? Okay, so there's one at 0 or 2 pi, and we would have to decide based upon the interval. So up here the interval says from 0, and I include 0 but not 2 pi. See up there? So I'm going to include 0 instead of 2 pi. What's the other place where the y value is 0? At pi. Good. Okay. Now if I solve this right-hand equation, what would you do to isolate the cosine? Subtract 1, so I'd have negative 2 cosines is equal to negative 1. Then what would you do? Divide by the negative 2. So I have a cosine of x equals a positive 1/2. Okay, now what do we do? Okay, use your unit circle. And since we're working with cosine, what variable are we looking at? The x. So where on your unit circle is the x value a positive 1/2? Pi over 3 and 5 pi over 3. What's that? Yeah, because we didn't take a square root. So only time you use positive or negative is if you're solving an equation and you've taken a square root. You guys feel alright about that? That's all I have for examples today. Pretty straightforward.